Okay, make sure at the top of your paper you write page 141, 1 through 10. This comes from section 3.3, modeling with quadratic functions. You need to write page 141, 1 through 10 down. Okay. Directions are find an equation in standard form of a parabola. Each of these problems gives you 3 points, none of which are the vertex. If we had the vertex, it would be so easy for us to find the equation for the parabola. When we don't know the vertex, and we don't know the symmetry around the vertex, it's a little more difficult. We want the equation in a specific form, standard form. Parabolas in standard form. Does anyone remember what standard form for a parabola would be? Who's got it? Y equals ax, what? Plus bx plus c. Yep, good job. So, A, B, and C are problems we need to, values we're going to find. But it's a really long process, which is why we're only doing 10 of these. And a bunch of them together. Okay, I've actually already started writing steps on the board from last class. Would you... There's going to be a few more steps I don't have on the bottom here. Would you write down our first step? Step 1 is to plug in the easiest point into standard form. Y equals ax squared plus bx plus c. Plug in the quote-unquote easiest point. There's generally one point that looks a little easier to work with. Which point on number 1 do you think is easier to work with? 1, 0. There's zeros. Those are the easier ones. 1, 0. And 1 is your x coordinate, y, or 0 is your y coordinate, right? What do I mean by plugging in 1, 0? No, I took all the lids off. What do I mean by plugging in 1, 0? In the A spots, the X spots, and the Y spot, right? So Y is now a number. Dan, what number do I put in for Y? Good. 0 equals, we don't know capital A yet. Do we know X? What is X? 1 squared plus B times X, which was 1 plus C. Okay? Solve for C. Have we done this with your class already? There's 2. What? Oh, it says it on the board. You guys are so smart. Step 2, solve for C. Well, we have to do a little simplifying. Isn't 1 squared times A just 1A? Like there's something on the end of this. It's not writing. And plus B plus C. We want to isolate C by solving for it. Okay? Adam, how would we solve for C? Well, it's not actually on the board. It just says solve for C. It doesn't tell you how. Here's our equation. We have A plus B plus C equals 0. How do we solve for C? Yep. Subtract A, subtract B, so they cancel. We have to do on both sides. Subtract A, subtract B. So we get negative A minus B equals C. That's as far as we can go for C. Sometimes, especially if you're working with the point 0, 0, or when the x-coordinate is 0, you actually can instantly find the value of C. In this case, we don't know the value of C. For you brainiacs who are reading the board, what do we do next for step 3? Found in step 2. Okay? Plug in a second point. We're going to replace the C that we just found. So it doesn't really matter which point you do next. Any preferences? -4. Okay, plug in. You should also be keeping track of what you've plugged in, what you haven't plugged in. So you should probably write down which ones you're plugging in. And I label too x, y, so I make sure I replace the y with the correct number, and I replace the x with the correct number. All right. Derek, can you tell me when we plug in what we would get? Y equals, what's the y? Yep, so 5 equals, we're plugging into this function right here. Well, a times -4, there you go. But C we're going to replace with what we found in step 2, which is -a minus b. We're trying to get rid of all these letters. We don't want to be working with 3 variables. We want to work with 1 or 2 of them. Now, simplifying, we would end up with 5 equals -4 squared would make it how many a's? Yep, positive 16a. b times -4 is minus 4b minus a minus b. Okay, any ideas of what to do next? And it's not a step, that's right there. Combine like terms, good. We have 16 apples minus an apple is how many apples? 15 apples. And now we have, this looks like a pepper. It's supposed to be a banana. Yep. Maybe it needs a line, I don't know. Bananas have lines or something? Now it looks like a leaf. Okay, -4 bananas minus 1 banana is -5 bananas. It's not -3, it needs to get further away from 0 when we're subtracting. Okay? Unfortunately, we don't know the value of A or B, so that's as far as we can go currently. We have one more point to do. Plug in, what's the last point we haven't used yet? -2, 9, where x and y are in the point. Okay, would you plug that in and do that one on your own, please? Remember, you can see on step 3, we said plug in this, or step 4, plug in the third point, but replace the c with what we know what c is. Yep, we will in just a second. Okay, Rekha, would you tell me what you got on the first line when you first plugged in -2, 9? What? Plugging it in. The y is what value? There you go. Equals times -2 squared. Okay. Uh-huh. Ah, because C is minus A minus, oops, B, right? Yeah? Okay. So to go through, you should have got 4A minus 2B minus A minus B. And what do you do next? Like terms, we have apples, that looks like hearts, whatever. 4 apples minus an apple is 3 apples. And banana peppers, because that's what I can draw, apparently, is negative 2 bananas minus 1 banana, negative 3 bananas. Now, we don't know what A or B is, but we do know 2 equations, and we have 2 unknowns. What do we do when we have 2 equations, 2 unknowns? Apparently you've done this. What? Not factoring by grouping. That's something different. We do need to group them somehow, though. But it's nothing to do with factoring. Did you do this last year, where you line them up? Line them up. Actually, I don't want to do mine right there, because I need more space than that, so I'm going to put it over here. I told you they were involved, that's why we're doing your homework problems together. At least to start you off. Line them up. Those 2 I have underlined in yellow. 5 equals 15A minus 5B. And I line up my like terms. My constant equals my A minus my B. Those are the 2 equations I got that are underlined in yellow. So, if you're writing down steps, which you should be, step 5 was line them up. What we are looking for, if you remember from 9th grade, I believe you've done elimination, systems of equations with elimination. Okay, we need one of the variables to cancel out. Right now, if I subtract, I have 15A minus 3A. Would that be 0? No. What about the B's? Negative 5B minus a negative 3B, which means negative 5 plus 3B. Would that be 0? No. Which one would be the easiest to manipulate to get to 0? The A's. The A's, because I can make the 3 become a 15. But I want it to be a negative 15, right? Because 15 minus 15 would be 0. So how can I change 3A to be negative 15? Tyler? Are they close? Negative 5. We need to times everything. You can't just do it to one term, so we need to make sure we group everything and times on both sides by negative 5. I just do one big group, or you can do two groups, one for each side. I just do one. Times everything by negative 5. So the top equation stays exactly the same. But the bottom equation changes, because everything has to be times by negative 5. Jennifer, when we times all 3 terms by negative 5, what would we get? This one first. 9 times negative 5 would be negative 45 equals negative 15 what? Yep. Negative 3b times negative 5. Negative times a negative is a positive, and then 3 times 5 is 15. Okay, I was hearing 27. Okay, so plus 27b. Now, oh my gosh, I was just like, it's not 27, and I wrote 27. Sorry. 15b. Happy? Okay. Now, let's subtract your columns. 5 minus 45 is negative 40. Not negative 50 because the 5 is positive, right? And our A's, this is exactly what we wanted, they cancel out. Our B's is negative 5 minus 15, which is negative positive 10. I'm just testing you. Okay. 10, -5 plus 15 is the same thing as 15 minus 5, which is 10. Yeah, divided by 10, so what's b going to be? -4. So we finally found one of the letters! Yay! We are not done. We're getting close. I told you it was involved, which is why I'm not assigning this over the weekend. This is why this is a homework problem. There's only 10 of them, so we're doing one today. Okay. So these problems make you feel so good by the end because you put so much effort in, and then you finish and you check and you're right and you go, yes, I did that. And then you go show everyone this beautiful math paper that you did, and you frame it. Well, it's a little disheartening if you get it wrong. Okay, we're not done, guys. Okay, on our steps, we lined them up, and we solved by elimination. Let's see. So, I guess first we had to make sure one would be canceling out. Yeah, we'll just put solve by elimination. Okay, now that we have B, we're going to plug in. Step 6, plug into one of your A, B equations. Okay, usually there's one that looks easier. Do you want to plug into this one or this one? Those are about the same level of difficulty in my opinion. This one just probably has smaller numbers, so maybe we would use the second one. Yeah? Okay, because I was seeing -5 and -3 here. I would have to change both of them. I would have to times this one by 3 to make that a -15, and this one by a positive or -5. I would have to do both of them to make them match or be opposites. But this one's 15, I can already manipulate the 3. I only have to change one of them. And if this is positive, I have to have this one being negative. So that's why we chose -5, because 3 times -5 would be -15. Okay, now we're going to plug in to one of those. It can be either one. Plug. Plug in our B that we just found. 9 equals 3A minus 3 times B. What was B? -4. So now there's only A there. You can find the value of A. Inverse operations. Solve the equation for A. Put it up in the air when you have the value for A. That's not the answer I got. Yeah. What are you showing me? Yep. Yep. It's not 4. The version's showing me 4. It's not 4. That's right. That's right. So first you have to multiply these two. -3 times -4 is +12. Then you subtract 12 over. What's 9 minus 12? -3 equals 3A. Fatima, how do I finish solving for A? Divide by the +3. Good. So we get A equals -1. We're so close to being done. We know A. We know B. What's the last thing we don't know? C. Do you see any equation where we could find C? Yep. This first guy right here. So, again, we plug in into -A minus B equals C, but in our case, A is -1, so be really careful on signs. It's a -1, because it's a -A minus whatever B was, but B was also a negative, so it becomes a -4. It will make a positive equals C. So we get little squiggle, +1, little squiggle, +4 equals C. So what is C? C is 5. So we can write our answer. Y equals ax squared plus bx plus c. Y equals, what's A? Negative 1x squared plus b. What was b? Negative 4x plus c is positive 5. This is one gigantic problem. But I'm going to put stars around it because we finally finished. Okay? Y equals ax squared plus bx plus c. I know, right? But hey, wait, we can do one more. This is all homework problems. You're getting points for this if you're writing it down. Okay, and now we'll go a little faster because you've seen the steps. We need to add to our steps. We plugged into one of the AB equations, and then we plugged into and solved. And then we plugged into the C equation and solved. And then we wrote our step 8. You write your standard form equation. Equation in standard form. Yep. And the best part is, your calculator has a program that does it all for you. I know, but I will show you that later. Let's look at number 2. You have to know, if you never learned that 2 plus 2 was 4, and you just type in your calculator, you never know how your calculator actually got 2 plus 2. You have to learn the background before you use a calculator. Let's try another one. We can do it faster this time. This time it gives us a table. In a table, aren't those just 3 points? Okay, Kyler, can you read on page 141 what the 3 points in that table are for number 2? 141, number 2. Excellent, thank you. Okay, we're going to do this. Last problem. Remember, you don't have to think about it all over the weekend. Yay for that. Because you're going to be thinking about factoring over the weekend. First step, plug in the easiest point. Well, none of these have a 0. I would go with probably 1, 3 because it's positive and it has a 1 in it. You can really do any, but I would probably say that would be the easiest one if I was to choose. Yeah, eventually we're going to have to do all of them. Exactly right. Plug in 1, 3. Remember standard form. As y equals ax squared plus bx plus c. So go ahead and plug in 1, 3. And then we solve it for c. Yeah, I should probably start this problem on a new side. Because as you can tell, it takes a lot of room. At least a half page, if not a full page, depending on your writing size. Okay. Dylan Darter, can you please tell me your equation you got when you plugged in 1, 3? Can you just tell me how to do it now then? Y is what number? Yeah, we're plugging into y equals ax squared plus bx plus c with the numbers 1 and 3. What? Step 3 equals what? Do we know A? Are one of these capital A? We don't know A. Do we know X? 1 squared plus, do we know B? Do we know X? 1. Do we know C? No. Does that make sense? Okay. So we get 3 equals 1a plus b plus c. That's why you'd want to use the 1, because the equation is pretty simple. How do we solve for c, Ryan? Good. Minus, that was not straight. Minus a minus b, both sides, minus a minus b. So don't forget about the 3 though. 3 minus a minus b equals c. And we will use that at the very, very end, and whenever we plug it into the next 2 steps as well. Okay? So first point done. Now what? Pick a different point. Which one do you want to do, Cassie? -1, -1, okay? Everyone, plug in -1, -1, where x and y this time are both -1. And when we get to the c part, what should you replace c with? 3 subtract a subtract b. Yep. So I'll rewrite this so you can see it, and you don't have to flip back. Okay, what is y? So write -1 equals, do we know a? Oh, good. Yeah, that's right. Do we know x? Mm-hmm. Squared plus, make sure there's negative, yep, plus c, and then you need to simplify. What is -1 squared? -1 times -1. And negative times negative is a positive. So it'd be positive 1a. So we have -1 equals positive 1a, so just a. What's b times -1? -1, b times -1 is -1 b. Well, we know c. c is this stuff, so we need to replace c with that. And replace, this should be a negative b. Because b times -1, that should be a negative b. And c we found on last time. c is this. Okay, this is what you should have. Check your work, please. We should have -1 equals a times -1 squared, parentheses are important, plus b times -1 plus c. Any questions on that first line? Okay, what is -1 squared? Positive 1, a. What is b times -1? Negative b, and c is actually right here. C is 3 minus a minus b. So positive 3 minus a minus b. Any questions? Okay, Cindy, what do we do next then? Combine like terms. We have our apples. Okay, if I add up my apples, oh, no apples. This is a nice problem. The apples are gone. So we have bananas. How many bananas that look like weird leaves? -2b plus 3. Solve for b. Put b up in the air when you know b. B up in the air when you know b. Not quite. I think you need to divide still. Those are right. You have the work. Put b up in the air when you know the value of b. Yep. How about this back row? What's the value of b? What'd you get? There you go. Okay, solve for b. It moves away from b first. Yep, so inverse operations. Good. Look at your signs. This should have been a when you divided away, this should have been a -2. See that little negative sign that you didn't We didn't carry it down here, which means you need to divide -4 divided by -2. Okay. I have a sign error. Yeah. This should be a -2b. You only put +2b. Alright, good. It should be +2. -3 minus 3. We have -4 equals -2b. Divided by -2, divided by -2. B is +2. Okay? What's the next step? Plug in the next one and replace C with what we know. Oh, we actually know something else. We might as well replace it. What else do we now know? We know B. Okay, so plug in our last one. Is 2, 8. We have our X and our Y. Hey, Kevin, what would this turn out to be when we plug it in? Huh? What was C? Okay, and we actually have a value for all of those B's, right? What is B? 2. So now I'm going to go back through and change my B's to 2. Well, I might as well do some work. 2 squared on my A makes that 4A plus 2 times 2. All the B's are 2. So we end up only having A's, which means we can find the value of A. We combine like terms, how many A's do we get? 3. And this is really the number 4. So we have 4 plus 3 is how much? 7 minus 2 is 5. So plus 5. Solve for A. This one's actually a nicer problem than the first one. You got it? What is A? Maybe? Yep. Nope, not 0 actually. Don't you get 3 divided by 3? 1. So we subtract 5. We get 3 equals 3A. Divide by 3. A equals 1. Sweet. B is 2. A is 1. Brindy, if we know B and A, how can we find C? This one? Exactly. Plug in. So A was 1, B was 2, so what's C going to be? 3 minus 1 is 2 minus 2 is that what you were telling me earlier, Rekka? She was a step ahead of us. C is 0. Is that our answer? Equation form, and we're done. Y equals, what was A? 1x squared plus, what was B? 2x plus, what was C? Do we need to write plus 0? No. Okay. Done. Hallelujah. Because the second step, the A's canceled out. So we instantly found a value of B. Hey, don't lose that though. Those are worth points, and we will continue working with the day of test if there's time after the test. And you don't have to worry about studying that at all until after Tuesday, or on Tuesday night, I guess. Which problem? The first problem or the second problem? Okay. Please bring your calculators back. Good job today, guys. Make sure you